All right, those of you that are using a graphing calculator to do problems like 4, 5, and 6, problems 4 and 5, you're using what's called a normal CDF. So let me clear up some space here. All right, the format, oh, by the way, normal CDF in your textbook under check notes where they show you in the textbook how to do this stuff. Normal CDF is on page 301. Instructions and an example. So you might want to look back over that. The format for this is normal CDF, and then in parentheses, you want to put the lower bound, the upper bound, and mu, mean, and sigma, the standard deviation, okay? Now, notice that for problem number 4, it's a Z value, okay? Not a raw X score. So you need to remember that when you're looking at a Z value, the mean is 0, and the standard deviation sigma is 1, okay? Negative 2.20 is our lower bound. 1.30 is our upper bound, okay? So I'm going to go to my graphing calculator over here. And I'm going to press second, and then distribution, which is above the bars key. And I want item number 2, normal CDF. I'm just going to press 2. I'm going to clear that out. Now, on my calculator, I have to enter information and then paste it. Yours might actually appear like this right here, where you enter the lower bound, comma, upper bound, comma, mu, and sigma, okay? My lower bound is the negative 2.20. I'm just going to type negative 2.2. And then I'll arrow down, or you can press enter. My upper bound is going to be 1.3 or 1.30. I'm just going to type 1.3. The mean is already set at 0. So for standard normal, that's correct. Notice sigma is already 1. I'll arrow to paste. I'll press enter. It'll pop this stuff up here. I'll press enter again. And there we get it. 0.8893 is what we found by looking at the table, right? To the 10,000th place. I'm going to clear that off. Looking at problem number 5, check this out. With a calculator, you don't need to change the X values to Z values. So what I'm going to do is enter normal CDF. For the lower bound, it's going to be 7. The upper bound is going to be 9. The mean of this distribution is 5. And the standard deviation sigma for this distribution is 1.2. That's the cool thing about this. You don't need to change it to Z values, right? So I'm going to go back into the second distribution. Option number 2. Now I'm going to type over this stuff. My lower bound is going to be 7. My upper bound is 9. My mean is 5. My standard deviation is 1.2. Paste it and press enter. And we get to 0.0474 here rounded to the 10,000th place. Now, again, this is more exact than your table. It carries the computations out farther, right? All right, last problem. I can't scroll up anymore. Last problem. Find Z such that 97.5% of the curve lies to the left of Z. This is an inverse normal distribution. The inverse normal distribution is mentioned starting at the bottom of page 305. And the format for this is inverse normal, and then you type in the area. In our case, it's 97.5%, comma, then you type in the mean, then you type in the standard deviation sigma, okay? So we're going to type in on the calculator. Well, first let's go through it. Second distribution, I want inverse normal. This is option 3, okay? My area will change 97.5% to decimal, that's 0.975 eventually. Here, my mean, notice it's a Z distribution, right? So my mean is 0, which is already there. That must be the default. I didn't realize that. And the standard deviation for a Z distribution, right? A Z distribution is 1, which is already there. We paste it, we press enter. All right. Z values are rounded to the hundredths place, right? That 1.5, 9999, and so on, whatever's there. We're looking at rounding that to 1.96, which is exactly what we got by hand looking at the table. So there you go. Make sure you study good. Contact me if you need to with any questions.